jump rope, but nope, I just can't do it.
What is up? What is up, you guys? We are back at it again. Another epic day here in the 100 Days of... Why do I hear myself 2 times? What? There we go. Is it... Hold on. Let me fix this setting real quick. This one, or maybe it's not in this one. Here we go. Let's go to live. Is it in this one? Here we go. Let's go to live. No, it's still in this one. All right. As you can see, No, it's still in this one. All right. As you can, we got a little bit of a different setup going on here. So hold on one second. Let me go ahead and fix this whole audio issue. This is getting quite interesting right now. This is getting quite interesting. Where would it be? I swear. Hold on. Let's turn that down. Let's check the streams. That stream is muted. This stream is muted. What if I just mute myself? Whoa. Hold on. There we go. Now I'm muted. Sorry, you guys. Give me like 2 seconds. Figure this out. Do I have another stream open somewhere? If not, we're gonna have to like, I don't know, go without the chill music or something today. Because this is very, very weird indeed. Is it on this one? Nope. Not quite sure. What is going? How are you guys all doing? All right, how you all doing? All right, tell me about your day. All right, let me buy some more time here, real quick, before we continue on. Hopefully the audio stuff isn't as cancerous for you guys. Leave a comment if it is pretty cancerous and noticeable. Oh God, because I can notice it. I can notice it a lot right now. All right, I can notice it a lot. It's something with the screen capture here. I'm not quite sure what is. Oh my God. How about this? That do anything? Oh, let me turn it on. Hello? Do anything? Oh, so now it sounds even worse. Testing. Does this one do it? Oh. Testing. Does this one do it? Oh, no. Okay. I hate it without audio, but I think today's gonna have to be. Holy crap. Okay. I think today's gonna be a no audio or no background music. No background. Testing. What the heck? What is going on? I literally. Holy crap. I'm about to. Does it go away? I have my computer muted right now. Does it just go away when my computer's muted? Milo says echo, echo, echo. Oh gosh. You know, I feel like NVIDIA right now, they had a great time today with their stream. Probably started, what, like 20 minutes late? Because YouTube was no bueno for them. It was just not working at all. And I feel like them right now because this ain't doing it right now. This is being all sorts of cancer. So, hold on. Show you guys. I ain't crazy. We aren't streaming here. We aren't streaming. Oh. Get out of here, you stupid Twitch. Oh, it's always these Twitch people, man. Always with Twitch that messes everything up. Okay, now is everything back to normal? I got my audio on. I don't hear anything. Let me put it on the video capture. Video capture sounds fine now. There we go. We get the lo-fi music. All right, we're working. We're back in action now, bro. It's Twitch. All right, the people right now. I see you guys watching right now on Twitch. Well, you gotta watch on YouTube, right? Even though it wasn't this time, it wasn't really Twitch's fault because it was from this site. All right, and it wasn't muted. I'm still blaming it on Twitch, all right? So as you guys can see today, we have a little bit of a different setup. I'm not currently at my normal streaming location. I'm out abroad in the beautiful Pacific Northwest right now, hanging out with, you know, Microsoft, giving some handshakes. We're talking about Bing, how awesome Bing. No, I'm just kidding. All right, I'm just kidding. But but we are using Bing right now. All right. So if you are just joining, we are on a roll using Bing as our only Googling option, or I should say Binging option, so we can test out the new chat features and see if it's actually worth it, and whether it's actually worth changing to. So far, it's been pretty impressive. Additionally, Copilot. But before we move on any further, if you guys don't know, we are Rootkit nonprofit organization here in the US of A. Don't go to college. Don't go to any other boot camp. You're already here. You're already watching. Complete it, get certified, and get a job. It's really that easy. We're the best in the industry for a reason. All right? No one else is even comparable. On top of that, we do a lot of free giveaways. The new giveaway is not live right now, but we just finished up with our week 12 giveaway, which we will be polling the winners today. We have 3 winners to poll, all right? 2 t-shirts in 1 mystery item. We are going to be polling those today at the end of stream. So make sure you stick around and see who is the winners for that. And I'm gonna need to get the list together because we do have an end of the month giveaway to do for people that have been chatting in the stream. So maybe we'll do that one tomorrow. I'll keep you guys posted, but we will be doing the end of the month streaming giveaway for all those that have been participating so far. Alrighty, let me turn this down just a little bit, make sure it's not too loud. Alright, and on top of that, there's a link in the description of this video, and if you're on Twitch, it's somewhere down below, where you can donate today. We are a non-profit organization, so all donations are 100% tax deductible. Avoid your taxes, donate today. On top of that, depending on how much you donate, you can unlock certain rewards, like our epic stickers, our collab t-shirt, and our epic sweater. Alright, super epic, all of them. Go grab one. Limited edition, the stream's almost over. When the stream's over, so are all the limited edition sweaters. They're going bye-bye. All right. All donations are matched 1-for-1 for the first 10,000 donations. And we have pillars along the way, like streaming for 24 hours straight, shaving my head here live on stream, and the goal no one wants to see, shaving my beard. No one wants to see this epic thing go away. All right. So we shall continue. Are there any questions from the previous days before we journey on to our next topic here of threads? And I guess as always, I am over in the Discord. So if you are a Patreon or Discord premium member, go ahead, hop into the Discord, hop into the events chat, and at any time, feel free to ask any question. All right. Feel free to ask any question. You don't need to just type away like all the normies. Let us go ahead and check questions here. Where is my streams? Here they are. And Milo says it's fixed. It is fixed. Thank the Lord. All right. So I don't see any other questions. If you guys do have questions, like always, make sure you drop them into chat and we can go ahead and answer them. I am on a Mac computer today, so it's going to be slightly different than our normal Windows flow. Not by too much, but just stick with me. There will be slight variations. I guess I shouldn't mess with the camera too much here. So threading. We left off on threading last time. What was it? On Saturday? Last Saturday when we were chatting. And we were just getting into it. We left off with talking about, you know, I should go experiment with it. My little example failed. So I got that example working here now. Because there's just little nuances that I don't really remember too often. Because, again, like a lot of things, you can use the default vanilla threading library, but there's usually some extra libraries built on top of that to do a lot of the annoying nuances for you. All right. And so that's usually what I utilize. So it took me a second. I had to go do some Googling to figure out what I was missing because I knew I had everything except for one little bit, and we got it now. All right, we got it now. So, threading. Recap. It is a way for you to run multiple things at the same time on the same process. Multiprocessing is running multiple processes at the same time. Multiprocessing is usually preferred in Python because that will give you true multi-threading, because threading in Python is kind of a lie by default. All right, it's kind of a lie because of the GIL. Modules that you import will not be affected to a certain extent. Some of them won't be affected by the GIL because there is an option to turn it off. Specifically, if you're building your module in C/C++ and importing it over, there are options to turn it off so you can empower your C/C++. If you're using machine learning libraries, because I know a lot of you guys that are just joining us now are coming because a lot of our AI aimbot videos have popped off recently, that is all automatically done behind the scenes, the full multi-threading, everything. All right, there are also lots of libraries that you can utilize to do multi-threading properly without being messed up by the GIL. All right, so there's a lot of ways to get around the GIL, so don't worry too much about it. If you are programming in another language, then you don't really need to worry about this too much because they will have proper multi-threading that actually functions how it's supposed to fully. All right, it's not going to be just stuck on the same main thread. Now, we talked about how threads can have shared memory. That's where my little Python example went wrong. And the shared memory example is to show why you would want to use locks. All right, locks on your data. Now, there's a lot, so I guess another way I could have done this is using a file and multiple reading from it. But showing how you can potentially get a race condition, which is, again, race condition. Some things are going to go faster than others, causing a potential error. So I pre-wrote up some of this code here. So from the threading library, I have a number that we've chosen. All right, it has 1, 2, 3, 4, 5, 6 in it. Doesn't really matter what this number is because we're going to overwrite it. We're going to overwrite it. Now, we left off with this even and odd function here, which we still have, right? This even and odd function, which we still have. Inside of this even and odd function, we are going to be referring to, so global is a special keyword in Python that means refer to the variable called whatever the name of the variable is here, to the global state of it. The global state of it is whatever is going to be all the way over, all right? All the way over, touching the border here. This is the global variable, my number, because it is outside of any scoping, all right? It's outside of any functions, it's outside of everything, all right? So this means that I can access the variable my number inside of this function. This was declared on the main thread, and so it's going to be shared memory across over to this, all right? Shared memory across over to these. So it's just a way for us to show that threads can and are capable of sharing memory, sharing the same pieces of memory in the stack or the heap. Now, we already showed how we can print and how the printing gets intertangled last time. So that looks pretty standard overall. The only addition is the global. And then at the very end of our even one, we set the number. I guess we should set an even number here. So we'll set an even number of 10, and for the odd one, we'll set an odd number of 5. All right, so my number will either be 10 or it will either be 5. All right, and if we go ahead and run this, we're going to see they're going to run, they're going to join in, and then right here, we're going to print out what my number is. All right. And that's pretty much it. So let's go ahead and run this multi-threading. And you're going to see that the number is 10. All right. And we got our output here showing how the threads are running, independent of each other. They're not being blocked up by each other. Not all of odd or even is running first before the other one does. They're both running at the same time. All right. And then at the end, because they're both running at the same time, it's unpredictable of what this variable may be. So right now it's 10, and if we rerun this, it's 10. If we rerun this, it's 5. If we rerun this, it's 10. If we rerun this, it's 5. If we rerun this, it's 5. All right. It changes every single time. This is a part of your race condition. Now, right now in this example, it's not really an issue, right? It's not really an issue because we're just demonstrating it. But per se, we were making an application that was waiting on some threads to compute, and then you wanted to do something with this information, like, I don't know, query some data from the database, or save this information to a database or to a file, or etc., etc. There's lots and lots of examples that are probably better than those that I can't think of right now. This can be a potential issue because there's no way to guarantee, like, is everything good? Is everything done? Is this the end result? Like, are there any potential other threads that are running? Like, what if you wanted the 10 to be first and the 5 to be later? Like, there's no way to really enforce a strict order. You could probably go around about it to a certain extent, but there's not really like a hardcore way to do it. So this is where the concept of locks come in handy, because you can lock up resources, whether it's a file, a function, a variable, whatever you want. You can lock it up until you're done computing on it, and then you can release it, free it up, so something else can then lock it up, do whatever computation it needs, and then free it up and go about its day. I guess another example, which I'm gonna try to think of the whole example off the top of my head here, would be in regards to banking. It would be really great for you or really inconvenient for you if you were like withdrawing money and depositing money and maybe doing both at the same time. And because you were doing both at the same time, what's the classic example here for, you know what? This is a great time to bring in our boy Bing and see if they can generate this classic banking example for us. So let's go over to Bing and let's go over to the chat section. Let's make this a little bigger. And let's say, what's the classic bank threading example for using a mutex? Let's see what it brings up for us here. All right. Why think harder when you can think smarter? All right. Let's see. The classic bank threading example for using a mutex. A mutex is a type of way of locking up a resource. All right. Is when multiple threads are trying to access a shared resource like a bank account at the same time. In this case, a mutex can be used to ensure that only one thread can access the shared resource at a given time, preventing race conditions and other synchronization issues. For example, in C#, when a thread calls wait1 method to acquire mutex, calls the wait1 method to acquire mutex. If the timeout interval elapses, well, this didn't fully explain the example, but multiple things accessing your bank account at the same time. Let's say withdrawing, right? Let's say withdrawing. It would be bad for the bank if you and someone else that was on your account, let's say your boyfriend, girlfriend, whatever, wanted to dupe the bank system. You only have $100 in your account. Maybe that's a little too generous. All right, let's do $20. All right, you only got $20 in your account. All right, I know you have a bad addiction to CS:GO skins. All right, look, I don't understand it, but look, you gotta quit. Now let's continue with our example. All right, so you have $100 in your bank account. You and someone else both on your account, and they both, or I guess at ATMs, and they both click on the withdrawal button, withdraw $20 right now, bam, at the exact same time. Because the bank, in this example, weren't using mutexes, both processes spun off. You tried to get money out of the bank account, and you were both able to successfully withdraw $20 at the exact same time. Because the bank system got a little confused because it spun off two threads, and at that single state, they were both looking at your bank account, and they both saw there was $20 in your bank account. So they said, oh, you want to withdraw $20? That's okay. I see there's $20 in there. So they both went through and withdrawed $20. Now, by doing that, now you have negative $20 in your bank account potentially. All right, that could actually go into another issue where your bank account actually just records 0 and you actually printed yourself some money from the bank. All right, so there's a whole slew of issues that can potentially go wrong here. All right, lots of issues, and you don't really want to mess up your bank account. So that's a potential problem for the bank. The same issue could occur vice versa when you're depositing money. It would be really, really annoying if you were trying to deposit your check of a good old $20,000, because you roll like that. All right, you're trying to deposit your 20K check, and at the same time you were depositing your check, your repeat Amazon order for the latest manga, all right, just went through, and it deducted your account to a new value. At the same time, it was trying to update your account by $20,000. But the update got overwritten with the manga purchase and what your new bank account amount should be. So instead, you just lost $20,000, and yeah, things didn't go good. All bad things that mutexes can solve, and not just mutexes, locks in general. So semaphores, mutexes, and pipes can all help with this. Any questions so far before we chug along here? Let me check Discord. All right, I don't see any questions. So like always, go ahead and drop in a question if you guys do have any. Let's go ahead and chug along here. So all this gets solved with locks. So locks are very, very simple. I get a lock, everyone else screw off until I'm done. All right. So when you have two items trying to go at a resource at the same time, they will first request access, and only one of them will get access to that resource. The other one will be told to chill, all right, to wait, and they have to wait. So that way, one thread or one process first completes whatever it's trying to do in its entirety, and then we'll release the lock on that resource. So then the next transaction or whatever is trying to go on can then proceed without them interrupting with each other and things going awry. All right, it's really that simple, right? It's just taking turns, because computers by default don't know anything. They don't know any better. All right, it's wild, wild west. Anything goes. You have to enforce your will and your own order upon the systems. All right. Again, like we've said before, you're effectively playing God mode. All right, and there's a lot of micromanaging you have to do when you're playing God mode. All right. Let me double check, make sure there were no questions that rolled in, and I don't see any. So let's go ahead and chug along here, shall we? So how do we go about doing locks? We talked about mutexes and other weird names that you may not remember. That's fine. Just Bing it, all right? Just Bing it. You can also look up the Python docs. I think they only refer to semaphores by name, and then they have just another item that's just called a lock, all right? There's more specific terminology for the names, I think is probably more common when you're at lower level languages. Like when you're in JavaScript, you won't really be messing with those names either, even though those are the core processes running behind the scenes. It's more so, I guess, when you're using things like C, C++, C# doesn't even like per se use the term mutex. They use this, I guess, wait one. And it's running a mutex behind the scenes. So I don't know. It will all be in pretty much every language. The terminology may vary very slightly, but at the core, this is an operating system function. All right. So if we want to Python create a lock on a multi-threaded resource. And I think I spelled this wrong. And I didn't spell it any better. Whatever. Let's see how it does with my misspelling. There we go. It corrected it. So let's see if you do have any questions. Again, you can use these new tools. It's not cheating. It's just being smart. All right. So we're getting our example code here outputted, which is really, really great. Now, again, like you've seen at times, the example code sometimes is right, sometimes is wrong. So make sure you test it, and there might be modifications you may have to end up doing. But for overall, it's actually pretty accurate. So it looks like there's a thing called lock that's a part of the threading library pre-built in. We must predefine this lock. So they're making this lock object and just calling it lock. And in here we can see we can use a with lock. And they're showing an example with opening files. So nothing else can potentially open that file and mess with it. And let's see here, .join, .start. In this example, we created a lock. With lock statement is used to acquire and release the lock while accessing a shared resources, in this case, a file. So it looks like when you use with lock, Python will auto magically, as it does with a lot of stuff for you, identify any shared resources and lock them out so no one else can use them until you are done. All right. So let's go ahead and see this in action, shall we? So let's go ahead and copy these two lines. This may be an example of maybe GPT here is failing us. We'll see in a second. All right, we'll see in a second. We might actually end up using their example here because ours might not be the best one. We'll see. So it's as easy as just making the lock, which we have, and then we're going to just do with the lock. And why are you trying to rewrite everything? I just want to indent it up. And it should just be as simple as this. So if we rerun our code, there we go. Looks like it's running, looks like it's working. And now you'll notice that it looks like the lock is working, which I'm surprised. But all right. Looks like it's locking something out. The main point is it is working. All right, it is working, and the lock action is working. It looks like the output is now predictable here. 1, 2, 3, 4. Okay, I see what's going on here. So as you can see, things are getting all locked up, and we've pretty much returned to, we are spinning off threads like normal. But we've returned to a pre-threaded state with using our lock here. A pre-threaded state. As you can see, the even numbers print first and the odd numbers print second. We would have to look in the docs because I'm not quite sure on the top of my head the reason for that. It's either that lock is the locked resource, so this must complete in its entirety first before this lock is given up, and then odd can start executing. It's either that, or because this is printing out. Again, printing, as we talked about before, is a file. It's standard out. So it might be locking up standard out until we are done with it. A way we can test this very simply is we only care about this number assignment and we want this to be locked up. So if we remove our for loop from this, all right, if we want to test or guess here, because we're just guessing right now, we haven't looked at the actual Python docs, we're guessing that since we know output goes to standard out, and that is technically a shared resource, a shared file, maybe that's the issue that's going on here. So we're going to tab that out, and we're going to tab this one out. So it's no longer in there. And then if we rerun, it looks like we are getting a slightly different result. There we go. As you can see, our printing is now slightly different, but we are consistently getting the number 5 as our final number here. So I'm assuming our hypothesis is correct here. As you can see, our output again is different because we removed it out of the lock, but our number assignment here is always the same. I'm assuming this is correct because even gets launched, this thread gets launched first and only runs once. So most likely this is being able to run first before the odd thread runs. So it's mostly also a race condition right now, in the sense that if you depended on it to always be 5, you might be right most of the time, but there is a chance that you're going to be wrong, and this may be 10. But yeah, any questions on that before we continue on forward here? Checking all the discords and the other chats here. So as you guys ask any questions, pretty much when it comes to threading and multiprocessing, it's not really a extra bit of really knowing stuff and complexity in the normal sense per se, where it's like really hard to set up and get working properly. No, not really that. It's more so design wise. Multi-threaded applications are great and super powerful, but it takes a little bit for you to sit back, relax, and think about the problem a little bit more thoroughly, just to ensure you're not going to run into any potential issues. Now again, your race and deadlock conditions are only going to occur, period. They will only occur, period, if you have multiple threads utilizing the exact same resource, right? So for example, if you had a game that is doing auto saving, all right, or manual saving, one or the other, you should pretty much always be fine, right? You should never really run into a race or a deadlock condition because the saving just is always dumping and dumping and dumping to a file. No one's really trying to read it. The only time anyone tries to read that file is when they quit the game and then start the game back up and want to load in. So using a thread for that would be pretty much 100% harmless. So you wouldn't have to worry about all these complexities. But if you were wanting to read a file from multiple threads, then maybe, all right, that's where you have to sit back and think, all right? Just because you're a programmer doesn't mean you're programming 24/7. Like we've talked about before, a lot of your time as a dev is going to be sitting, thinking, pondering. What's another word for thinking? Thinking, Googling, or I guess Binging, all right, and asking questions, all right? That's what you really have to start getting good at, as you've seen from all of our chats about Google searching and then now using Bing. Questions are what you got to do and what you got to ask in order to improve. One last check here before we chug along for any questions that anyone has. I don't see anything, so let's go ahead and chug along here. So again, threading, super epic, super good. Now, don't go throwing up a million threads. All right, just because you have a million threads running doesn't mean that your process or threads or a million processes doesn't mean that your stuff's going to run at light speed. No. It eventually will get congested. What do I mean by that? Think about it like a road, all right? Like a road. Your CPU has multiple cores on it, and those cores can handle one thing at a time, all right? Threads are an illusion, right? Threads are an illusion for the most part, that you can do 1,000 things at the same time on a CPU that only has 6 cores, all right? It's an illusion that your operating system conducts in the background to make it seem like this is all happening at the same time, but in reality, it's not. Think of it like a highway, all right? And every lane on this highway is a core of your CPU. If your CPU only has 4 lanes, 4 cores, then you making a million threads, aka putting a million cars on the road, just ain't gonna be that great, right? You're gonna clog things up. It's actually gonna run slower than if you were only to put 1,000 or 100 cars on the road, all right? Yeah, those cars may be buses, so they take up a little bit more room, but one large bus with a lot of people on it is a lot easier, to potentially crunch through than 10,000 cars, right? It's going to take up less volume. So it's a fine balance, right? It's a fine balance for multi-threading and multi-processing based off the amount of cores that you want. Now, this all depends potentially on the language you're using and from your own testing. There are rules of thumbs, basic rule of thumbs that you should follow in regards to how many threads you should run and how many processes you should run. I believe, we'll go being this in a second, that pretty much you want to max at 2 processes per core, all right? Ideally 1 per core, but at most 2 per core, because effectively you're doing 1, process per core. And then for each process, you could potentially have, I think, 5 or 10 threads is ideal for each process per core. I can't remember for the threads too much. But let's go and see what Bing says here. What is the ideal amount of, let's do of processes and threads per core? So let's see what the good old internet says. All right, so the ideal number of processes and threads per core depends on the specific application and hardware being used, because that's the answer for pretty much everything in the programming world to an extent. Is it just depends, all right? A single thread per core is ideal, but applications often use larger multipliers such as 2 threads per core, due to bugs and inefficiencies in their code, such as operations that block when none should. For example, if you have 8 cores, each of which support 8 threads, you could have 64 processes running in parallel without context switching. Hope this helps. Let me know if you have any other questions. What are some other let's see what this also brings up. So you'll also see the terms thread and processes used interchangeably on the internet, because a lot of people don't really know the difference, and they'll usually always just spin up threads and not really extra processes. That is fine too, but in general, as you can see, the magic is 2. All right, so 2 per core is max what you want to typically be doing. All right, you can, of course, like all things, do a lot more, but for max efficiency, 2 is usually the max, right? 2 is usually the max you want to utilize, where you'll see the best performance. All right, any questions on that? Highly recommend, looking into this more if you are doing something that really requires a lot of multi-threading. All right, and then there is a certain extent, depending on the type of multi-threading that you're doing, where instead of using CPU multi-threading, it might be more beneficial if you offload it to your GPU. All right, because GPUs have potentially thousands of cores on them. A CPU likes doing lots of computations, like we've talked about before, in serial progression. And then your GPU is a parallel compute device, so it likes doing lots of stuff at the exact same time, right? The difference is the parallel compute stuff by default shouldn't really be dependent on each other. So every process that you have running should be independently computable, and shouldn't rely on any other item, because that's how it does, you know, potentially 10,000 things at the exact same time. Do they go up to 10K cores? Let's see. If you want a, let's just Bing it. How many cores does a RTX 4090 have? Yeah, 16K. So over 10,000. So you could do potentially, you know, 10K computes at the same time. All right. That's what makes GPUs great for rendering things and for machine learning, because I think machine learning is slightly different because of the tensor ones. Again, I'm not a hardware person, and my actual C integration for the C library programming knowledge for the NVIDIA GPUs is very limited. But for rendering, it's really great because a lot of the stuff you know beforehand. You just need to compute how it's going to look, and you can process a lot of these at the same time, which is way faster than the CPU. But again, they're different hardware for different uses, so it just depends. CPUs are always god tier above everything else because they are the most versatile. They're not the best at everything, but they're the most versatile, which conveniently makes it the best at a lot of things. All right, so let's go ahead and continue on here with a multi-processing example, shall we? So let's do processing.py. And let's go ahead and see if Bing will generate us a multi-processing example here. And I think I closed my tab. Chat. Python multi-processing example. Now remember, for your threads, they are very, very lightweight and will only include on each thread the bare minimum of that what it needs in order to run and execute. It relies on the parent process. But multi-processed items are completely independent processes that have their own independent stacks given to each other. All right, so they're completely, independent offsprings that do their own thing and then come back. You can't do shared memory resources with multi-processed items. All right, you have to send them all the information that you want them to have up front, or establish things like a pipe with them, or a can you do semaphore? I think you can do also semaphore with them, which is effectively a pipe where you transfer, just like how you would on the internet, how you contact a server and send data to someone, or receive data across the internet. It works the exact same way for these processes, all right, except it's all internal on your computer. So let's go and copy this. I really like this example it got for us. I don't know where it pulled it, but this is really great because it's very, very similar to what we have for our multi-threaded example, except now it's using processes. As you can see, setting up processes pretty much the same way you set up threads. They're very similar in how they function, all right? And similar on how you can execute them, and you can have them join back up, all right? So it's pretty epic all around on how they both work, and pretty much anything that you have as a thread, you could potentially make as a process, and vice versa. Of course, if you had shared memory items, it might be a little bit more cumbersome to go about manipulating or changing them back and forth. So let's go and run this multi-processing example. And multi-processing has no attribute process. So did this mess up for us on the code generation. Python multiprocessing pool. Yeah, process it right here. We just need to import pros from there we go. Let's remove this, and let's remove this one, and let's rerun this. From partially initialized module multiprocessing due to a circular import. It really did not like that. Well, like we said earlier, sometimes Bing gets you those good examples, and sometimes it be failing. What is this? No attribute process. All right, let's go here and look at our example straight from the what do you call it? The Python documentation. Again, as you are learning and progressing in your dev career, it's going to be better and better if you look and learn how to navigate docs. All right, because there will be a time in your dev career where you're going to be looking up something. You're going to notice there's going to be absolutely nothing on Stack Overflow or anywhere else on the internet. You're going to have to look at the docs. All right, especially when you get more into enterprise land. People aren't really posting as regularly on Stack Overflow for these items because you're getting to potentially trade secret area and just really expensive knowledge. All right, people aren't really that willing to share after a certain extent. So get used to reading the docs and figuring things out yourself, because that's what we'll eventually come to for you somewhere down the line. So let's go ahead and take a look at this example they have for us here. So they're doing from multiprocessing import process, which we had before. They have a function here called info, another function here called f, and then they have the main. So when we run this and launch it, it looks like we're going to have a new process that launches that runs the f function. All right, and the f function will take a name, which we give it right here, called Bob. It will take this name and then also run the info function, which is up here, and then it will print hello and then common name. Let's go ahead and run this and see what happens. Is it my Python version? Three 3.6. Partially in multiprocess, likely due to a circular import. We call this multi everything. Oh, is it because the oh, I think it's because the file itself is, holy crap, is called multiprocessing. And this one was called threading, so it didn't really have an issue. Let me rename this file to, I don't know, multi-tac processing. Let's actually undo. Well, I didn't want to undo that. I'm gonna undo back to our what do you call it? Bing example here, and see if that will work now. Python 3 multi processing. All right, there we go. All right, so difficulties due to our import. Again, Python import system, like all things that are simple, are great unless you do something wrong, and then it might be painful for you to figure it out. So we got the error of circular import issues. Let me see here. Due to a circular import, which is kind of confusing at first because circular means that it's potentially getting into a forever loop on the import there. And if we look here, process was missing, which it says here in the docs that process should definitely be a real thing. So if we keep reading through the error, we can figure out that it's looking for something called multiprocessing. Our file is called multiprocessing. So it's getting a little tripped up and confused there. So again, make sure your file names are good, are a-okay. Why? What is, okay, now it's mad at me again. Why are you mad at me again? Python 3 multi. List object cannot be interpreted as an integer. What did I just change? Are you kidding me? I absolutely hate this. For range 1, n, 2, numbers, list cannot be interpreted as an integer. Does this really want it as a list of lists? Why did you just work a second ago? Save, run. List object cannot be interpreted as an integer. This, save, run. All these stupid examples. Print n. Are there threads that are running that are all messed up? Let's grab this. Brand new, clean. Can you not? Grab this, brand new, clean, and rerun it. I'm not crazy, right? We just saw that it worked just fine just a second ago. All right, so I don't know what's going on, unless it was running the Python example from here. Oh, maybe it was running this one. Hold on, let's switch back. Maybe Bing was failing us. Okay, Bing was failing us. All right, screw Bing. All right, it did not do a good job. We're using the default item because I'm pretty sure this is what we got before. Yes. Hello, Bob. This is what we got before. All right, so just some save issues on my part. My bad, you guys, if that was a little confusing. So let's go ahead and chug along here before we go bring it up tomorrow. If it doesn't change, it could be test auth for now. Wrong box. I just saw your comments, my guy. My bad. Could be a test auth for now. Not sure what the test auth was for. But real quick, let's review this before we go on a quick little break. When we come back, we'll just round up our talk here about multiprocesses, and then we'll do our giveaway and we'll continue our journey tomorrow. So as you can see here, this works, and below we get main line. We get the module that we're currently in, which by default is going to be __ main __, hence why we've explained this before, hence why we have this if statement, or you'll usually find these if statements at the bottom. Again, this is not required. You don't need to do this. This is particularly for safety in regards to when you want your main to run and when you don't want it to run. If this is potentially a module you're building that people can import, all right, if they're importing your code, this will make it so your whole independent process doesn't just kick off, all right? It's safety. Only it will run via the command line when executed directly. So you're going to see here the parent process, aka our Python program that we're this file right here that we're running and executing has an ID of this, right? This is what the parent's ID is. If we were to do a ps tag elf here and look, we would be able to find that parent ID. All right. Let me go and rerun this again. This process that we kicked off by saying this is going to have this ID. All right. As you can notice, it looks like the IDs are wrapping around. So maybe I'm not a heavy Mac OS user. So if you are a heavy Mac OS user, you might maybe notice that this is almost 10,000 or sorry, 100,000. So maybe it ranges from 1 to 100,000 as the process numbers for Mac OS by default. I don't know. I'm just guessing from the numbers that we see here, because usually when you launch new processes, it will always be a higher number. It increments by 1. All right. So since this is wrapping around, it looks like it isn't using the main parent process numbers, or maybe this is a separate counter for child processes. I don't know. All right. I don't know. This is an operating specific thing. Next, you can see our function is executing. And since our function is executing, look at its module name. We haven't looked at module names too much before, but you can see here, module name is right here, underscore, underscore, and print, all right? Underscore, underscore, print. In here, when we run the script, this is what gets executed first, this info main line. This info main line is going to print our underscore, underscore name. When you execute it via the command line, like I said, it will be equal to underscore main. This thread is now being executed. It does not have underscore, underscore main. It has underscore, underscore MP underscore, underscore main. MP is not the military police. Don't worry about that. All right. This is multi-processed. All right. This is a multi-processed item, and this is the main function for this multi-processed item. This also, knowing this, allows you to potentially do some fun, fancy logic, because you can make multi-processed items self-aware, or threaded items self-aware, because everything has an underscore, underscore name. So if a thread is a aware thread and it's aware that it is a thread function, you could have it do separate logic than if it was a main function item. All right. And we can show that maybe off here in just a second. You can see that its parent process is this. Its process is this ID. All right. So maybe the parent process here was Visual Studio Code. And then this is, or the terminal here in Visual Studio Code. And this is the actual main Python function here running. This is the main Python function running. This is the actual process ID for the multi-process thread. And it says hello Bob here at the end. All right. It says hello Bob here at the end because that's what we have running right here. So hopefully that was a quick, dirty rundown for you and it kind of made sense. If not, I was chatting with someone else at the same time. Okay, I didn't see any other messages in the stream chat. So if you have any other questions, again, I'll go and post this link so you guys can grab the code straight up from the Python docs here. All right, it's just slightly down to this item. I'll go and grab this link and I'll go and post this on the YouTubes and on the Twitch, so you guys can copy and paste that code if you haven't already written it yourself. Let's go ahead and go on a break. So we'll be back in 3 to 5 minutes. When we come back in 3 to 5 minutes, maybe we'll show an example of making a thread that's more self-aware and how that can be potentially a very powerful tool for you, because again, we like things to be dry when we're programming. So this is a way you can make things dry, but also change the dynamic of it a little bit, right? So I'll see you guys in 3 to 5 minutes. Alrighty. Let us get back at it so we can finish up here, do our giveaway, and move along with our journey. We're almost on day 90. It is very exciting, all right? I'm excited, all right, to be done, take a break, and return to fun, spontaneous classes, all right? Most likely next week, we'll do at least one, if not two, machine learning classes. And we'll continue the machine learning classes. We'll probably do like 5 of them in total. And potentially we'll do some at the end of next month or end of this month. We're going to do some exploitation classes in preparation of our Hack the Flag. That is going to be next month. We have some information on it in the Discord. More will be coming out soon here. And then after that, whatever you guys like. All right, if you're not a supporter, make sure you become a supporter. And let's actually talk about that a little bit more. If you don't know, we are a Rootkit nonprofit organization here in the US of A. Don't go to college. Don't go to any other boot camp. All right, you're already here. You're already watching. Keep watching. Complete 100 days. Learn everything in our roadmap that you need to know in order to pass our comp sci cert. You get that. Look, it's just that easy. All right, you just get a job. All right, no debt, no nothing. All right, it's free real estate. All right, that's all I gotta say. It's effectively hacking system. I don't know how else to better describe it. All right. Now, if you want to become a slave to debt, you can give us 100K of your money instead. All right, and we'll give you whatever you want. All right, it's up to you. On top of that, we do regular giveaways during the 100 Days of Rootkit event. Our week 12 giveaway has just concluded. The week 13 giveaway will go up after the stream today. We are going to be pulling those items today. All right, so it's going to be 3 different items we're giving away, 2 t-shirts from what happened on the week 11 giveaway, and 1 more mystery item. Additionally, we are a nonprofit, so if you want to avoid your taxes and perform tax evasion, hey, you can do it right now. Just click on how much you want to donate and start donating. Avoid your taxes, donate today. Depending on how much you can, how much you donate, you unlock certain rewards, like our epic stickers, a collab t-shirt, and our epic sweater. All donations are matched for the first 10,000 donations. Those roll in at the end of the month. I don't think the donations from last month have rolled in yet, so I'm gonna have to send a quick message here to our generous donator to make sure they match all of the donations that came in from the what do you call it, from March. All right, as you can see, they donated a couple times here down below, matching the previous 2 months. On top of that, we have pillars like streaming for 24 hours straight, shaving my head here live on stream, the one no one wants to see, shaving my beard. No one wants to see that. All right, that's where all my knowledge is, except for my mom. My mom wants to see that. She's sick of this thing, but I think it's glorious. All right, a lot of people think it's glorious. All right, is it not glorious? Let me know if you don't think it's not glorious. All right. So we put into the description, or not the description, in the chats, the link here, so you guys can grab it and get your multi-processed example. It looks pretty similar to your threading example. This is just showing how you can have multiple functions in a process, because again, the process is going to be pretty much a duplicate of all your code. All right, it's a recreation of pretty much everything you have, except it executes slightly differently. And you can make it self-aware by looking at the underscore name here, which is really, really important for potentially getting lots and lots of power out of it. What do I mean by that? Well, let's say, we're running info here, which is running on the main function, but it's also running on all of our sub-processes. So we could potentially have a if statement in here that's looking to see if it is the main process or not. And if it is the main process, then we could potentially do some extra logic here that isn't seen in any of the other processes, right? So now if I rerun this, you're going to see that this runs even though the main function and the child process, all right, the one that we're launching here, is running this info function, all right, this info function here. Only the main thread will be running this little statement, right? So we can be, say, 1, 2, 3, 4, 5, 6. And if we want the child thread to run something else, we can say, I guess I just finished up that. It would be best if we be more specific. So we're going to do like this, multi-processed. There we go. This is supposed to be an elif. There we go. So now you can see that we get slightly different printouts here, right? Slightly different printouts. And it's not specific to this function because at any time you can call this if statement to see, you know, where it was originally kicked off. And then you can potentially change all of the logic. Now, multiprocessing and multi-threading are super essential to lots of everyday services. For example, you play games, multiplayer games, you connect to servers. Well, congratulations. Every single person connected to that server is running on potentially their own thread. This is where some of the limitations come in because remember, we just talked about processes and threads and going on the CPU and how that's potentially a limitation and how many threads you can run, etc., etc. That is still a limitation potentially for multiplayer games, right? CPU count is always going to be limited. When you have a multiplayer game, every single player that connects is potentially going to be spun off onto their own thread. So that way you can have multiple people alive and not blocking the server. Because if you can't really have multiple connections going on at the same time without different threads, or else you run into the issue where lots of blocking actions are happening. Now you can do logic to kind of make it multi-threaded. Not really, it's kind of like you cycle through each connection and you give them like 0.1 of a second to give you any info before it moves on. But you have to give them each their own thread. And again, if you want to make a server with 10,000 people, it's possible, but it's like putting 10,000 cars on a, 8, 16. Well, if you're running on a server, then it's going to be more like 256 laned highway. All right. Not going to be, you can do it. It's not going to be the most efficient thing in the world, but you can 100% do it. So we can use this knowledge here to potentially make our own server, our own emulated game server, where people or clients can connect to our game server, and we can then handle multiple people connected to our server at the same time and have them sending us data and requests and, I don't know, just doing anything that a game server needs to do. So I think tomorrow is when we'll start our journey. What day is it again? It's 85. So maybe tomorrow and the day after tomorrow, we'll focus on making a server, specifically some type of, I don't know, fun little game server where people can connect to it. We'll show off how to use multi-processing, multi-threading. Now again, as always with these examples, they're for learning from. So some of it maybe will be properly coded out. Some of it, I will make sure I let you know, is just going to be thrown together to show off how you can go about doing stuff, but it's not by any means going to be the most proper way. So we'll show you making a server, people connecting to it. We'll talk about sockets again, all right? Because we didn't talk about that too much, so we're gonna get back into that again. And yeah, it will be fun. So if you guys are interested in making games, this is gonna be very, very important. But for most of you that will be getting normal jobs, not doing game development, this is also gonna be very, very important. Not necessarily because you'll be making these from scratch per se, but so you can understand how a lot of the modules that you utilize that do a lot of this automatic logic for you, like Flask, for example, you know how they're working behind the scenes, all right? Any questions on that before we do our giveaway? It says, you are a glorious man, keep up the beard. Are you covering race conditions with multi-threading? I think we'll cover race conditions and deadlocks because we talked about them. We talked about the theoretical sense with them here with the even and odds. I think it's going to be better visually for everyone if we show them off making the game server, just some type of server and practical example, than these like one-off function examples. Because like the one here in the docs is a great example for me as a dev. I'm gonna grab this, makes perfect sense to me, I'm gonna move on. But for people that are learning, this is not a great example. This barely makes any sense on what's going on. So I think using for us taking at least 2 days to kind of make a mock game server for some terminal game, maybe it's our dungeon crawler, maybe we make our dungeon crawler multiplayer, would be a great way to show the race conditions, all right, and to show how deadlocks can happen and the actual reason for potentially running locks, because we'll work in there some way about, I don't know, data being saved to a file. So we'll have like 3 people connected at the same time and showing how that can get messed up. And then for race conditions, we'll figure it out, but we'll try to send a message all at the same time. So we can show that race condition happen when it gets to the server, or maybe vice versa. So you guys can see it more in real life. This is also, I see your thumbs up. You guys have seen race conditions before in real life, specifically like in ways like server desyncing, right? It's, I don't know, like and MMOs and stuff, maybe you drop something, you know, some people call it lag. This goes beyond lag. Well, it could be potentially lag. Depends on how the programmers made it and how potentially bad of job they did. But it can show itself as lag, or it can show itself as you potentially just losing items, right? Just completely losing items, or as a dupe where you can duplicate items, all right? Because again, we talked about the real world example of a bank, and that's a real world, very important example, right? Lots of people spend lots of time and money on banking systems and how to make sure they are just golden and you don't run these issues. But for video games, anyone can make a video game, so they don't really get taught or take the time to learn themselves about these issues. So that's why you'll see duping and also loss of items in games sometimes. Any questions on any of that before we end today's stream at all? Y'all are really crowding up on the Twitch. Just so you guys know, for all of you guys on the Twitch that are new, all of these are recorded and are on YouTube, and I guess they're on Twitch too. Look, we're streaming on Twitch. I don't use Twitch that often, all right? But all the past 84 days are recorded on our YouTube channel, so you can go over there and watch all the previous days, all right? So you don't need to feel like you've left out anything. And every single Sunday, asterisk, almost every single Sunday is our chill Q&A. So if you are starting right now, you can use the chill Q&A to ask about any of the previous 84 days. Any questions that you have. It's nothing but just us chilling and answering any questions. All right, sweet. I don't see any questions rolling in right now. I'm gonna wait 30 more seconds to see if you guys have any other questions. If you do have questions after the stream, make sure you go over to the Discord. Let me pull it over here. Make sure you go over to the Discord, and at any time you can go in and ask your questions here in the 100 Days of Rootkit chat, right? And we will answer them, all right? We will answer them. Please ask something, all right? Give me an excuse. You see this notification? I don't want to answer any more questions about the stupid aimbot, all right? Give me questions elsewhere so I can be entertained, all right? I'm done. I'm done with this stupid aimbot. So please entertain me. We will answer your questions about anything else. All right, anything else, please, I beg you. If you don't know what the aimbot is, well, go over to our GitHub and go check it out. All right, it's an aimbot. It's base code. All right, it's not meant for you to just go get 1,000,000 kills right away. All right, it's meant for you to get up and running, see how you can go about doing it, and then build upon it. I don't see any other questions here. So we're going to call that a day. So I will see you guys. Hold on. Where is it? I'll see you guys tomorrow on the next one.